Hello, everybody. Hope everybody's still doing well. We're gonna go through some notes here on 3.3. We're gonna move on to the next section, properties of logarithms. This is where we're gonna start to actually work with them, being able to solve. And in fact, some of the problems that we did previously, some of you I think have already figured it out how to do it on the calculator. But we're gonna learn a couple different ways we can do it on the calculator. I'm gonna show you a couple things here that actually will come in handy moving forward here. By the way, I will send you a copy of, not the completed notes, but the notes page that just looks like this. So that if you wanted to print them off and fill them in or do whatever you want, or just write down some of the things that are important to you as you go through the video, that would be good too. All right. So the first thing is called the change of base formula. Now, the change of base formula is a way to actually get answers to problems like, log base 2 of 3, because we can't get that answer. I don't know how to do that, because remember that means 2 to what power gives me 3, and I have no way of doing that right now. I know it's less than 2 and of course more than 1, but I don't know exactly what it is. I think on when we first kind of looked at that one, some people played around with it on the calculator to figure it out, just kept plugging in numbers until it worked. Well, the change of base formula allows you to actually get that answer, and I'm going to show you another way on our calculators that you can do it as well. What the change of base formula says is anytime you have a logarithm base a of x, we could rewrite it as logarithm base b of x over logarithm base b of a. Now, what does that mean? Well, what it means is we're going to use, this is the x, this is the a, we're going to have x here, a here, and then we have this b. Well, that b is just, they have to be the same, but we're going to use ones that we can use on the calculator, which is log base 10, or ln, which is log base e. Okay, so for example, I'm going to use this one as my example. So I could do one of two things on my calculator. I could do log of 3, because that's log base 10, over log of 2. Or, and we can get an answer to that in a minute, I can do ln of 3 over ln of 2. Okay, and that'll get me the answer to this. Okay, so let's look at that on a calculator. I kind of downloaded a TI emulator, it's called. It's a free version for 90 days. So this looks like the Texas Instruments calculator. So if I want to do that one there, I'm going to hit log and 3, got to make sure to end the parentheses, divided by log, oops, go back, delete, clear, log of 3 divided by log of 2. And that'll give me my answer. Now, watch if I'm going to, so that was at 1.584 or 1.585, I guess. 1.585. Now, we can do the same thing with the ln. So we could say ln of 3 divided by ln of 2 and get our answer. All right. So it's the exact same answer. So this is now a way that we can answer this question or any logarithm question. All right. Now on the TI, if you have a TI, which I know many of you do, there is a way that I can type just this in here as it is and not have to use the change of base formula. Now, the change of base formula, for those of you who don't have a Texas Instrument or a scientific calculator like that, if you need to use like a regular calculator like this one here, you can see I can go ln of 3 divided by ln of 2 and get my answer and get the same answer. Okay, so you can use the regular calculator. Now, if you do have Texas Instruments, how can you do this all in one shot? Well, you got to go to math. Okay, you got to hit the math button, saw what I did there. Now we have to scroll down. There's a thing called log base. It's right there, and I hit enter, and then basically I just type it in as is. So there's a 2, I'm going to arrow over, 3, get the answer, and voila, it's the exact same answer as what we got using the change of base formula. Okay, so that's how we can do this from now on, using our formula, the change of base formula to find our answers to our logarithm problem. So I want you to maybe take a moment here and pause this video, and I want you to answer those two questions using the calculator, however you want to do it. Okay? All right, take a moment. All right, so the first one would have been, and we could use the change of base formula here, so I could say log 16, or ln 16, sorry. Oops, I got to go back, end that parenthesis. And ln of 3. So 2.523. Okay. And the next one, the last one here, let's see, log 5 of 22. So let's use the log base formula again. I'm going to go this way instead. It's quicker. So we're going to put 5, and we're going to go 22. And 1.921. Okay, so that's how we can get answers to logarithm problems that we don't know. Like this one, I could not get it. I know it's some decimal. Okay, all right. So now for the big kind of moment about all of this work here, and that is the properties of logarithms. All right, and again, I'm going to send you a copy of those notes. These are included in there as well. Now you got to remember something. When I talked about a logarithm, I said the answer to a logarithm was an exponent. What did I mean by that? Remember when we said, you know, log base 2 of 4, and that question is asking, remember we used to say, oh, you can write a y here, so that's 2 to the y equals 4, so that was 2. Okay, so this answered 2. So a logarithm is equal to the exponent, okay, or the power. So it's got to behave like exponents or powers. What do I mean by that? Well, what do you do when you have x squared times x cubed? What do you do with the powers? Well, you add them. So 2 plus 3, right? Well, notice when we have a logarithm, the product property, when we are multiplying things, we can break it apart as addition of those two things. Okay, multiplication, addition. What do you do when you divide? You subtract. So 4 minus 1. Well, notice in the quotient, when you're dividing, you can break it apart as a subtraction. Okay. Last one might not be as easy to see, but what do we do when we have a power to a power? So in other words, 2 to the third. Well, we multiply. That would be 2 times 3. Okay, and so here, when you have a power, you have a logarithm with a power, and the power is right here. That power is going to move out in front so that it's multiplied times that logarithm. So that's how we get that, to remember that. All right. Now there's two ways we're going to use these properties. First way we're going to do it is the way you see them, they're written right now. In other words, we're going to go this way. I'm going to start with this side, and we're going to expand it out. Okay, we're going to write it as an expansion. And that's what we're going to play with on this section. But in the future, we're going to go the other direction, and that's more important, and that is condensing, bringing things together. In other words, taking these when you have a log and a log and bringing it together so that you just have one logarithm. You'll see that later. We'll do that in the next one. Okay, the next video we'll talk about that. All right. Okay, so let's look at some examples here. There's a few different ones. For time's sake, no, I think we can do all these. So I'm going to give some rules here, and I'm going to give you a couple. I'm going to do a couple of the problems out of the book as well. We're going to write these as properties or as logarithms, an ln2 or an ln5. I'm going to break them as 2's and 5's, in other words, and you'll see that in the directions. So for example, this, and there's no real reason, this is out of context. This is just practicing with the properties. So if I said 2 times 5, okay, how could I break that down? Well, that would be, since according to the property we just looked at, when it's multiplication, it becomes addition. So ln2 plus ln5. Okay, and that's it. That's all you're doing. You're not going to grab a calculator, get a decimal. This is just practice with the properties. Okay, so again, in number 2, we're going to kind of write some things as 5s and 2s, and this might look a little strange at first, but this is 5, and then this is 2 to the 5th, right? We want to make sure that that's a number. So if we break that apart, division is subtraction. Okay, but then we don't want any powers when we're dealing with this. So this will be ln 5 minus 2, or sorry, that should not be a 2. It should be a 5 of ln 2. Okay, in other words, that power goes out in front. So that's all we're doing. We're not, this seems a little strange just because it's numbers. I'm not going to do a lot of these in your notes. So this one, the idea of this, it's a little hard to see, but that right there is a 5th root. Well, the first thing we would have to do is write that as a 1/5. Okay, this is a different type of problem than the previous 2. Now, the reason I'm showing you this, I want you to see something here. So this 1/5 we can put out in front. But what do we know that is equal to? A log base 7 of 7. Well, anytime you take a log base of something and the same thing, they're equal to 1. So this would be 1/5 times 1, which is 1/5. Okay. Number problems, don't get too hung up. Again, I'm only going to give you like a 2 of the number ones. I'm going to give you a lot of the next ones because they're the more important ones. The more important ones here are dealing with actual like rewriting this logarithm as an expansion, and it's all in variables and numbers and things. Okay, so like for instance here, this is log. This would be base 10. We just wrote it as log. This is 3 times x squared times y. So the first thing you would do is separate it by addition. Okay. The only other thing to do here is that 2. We don't want an exponent, so exponents go out in front. So the goal with this is to write everything as sums and differences with no powers on it. Okay, and so that's the idea, is that we want to separate this. Now, there's no, I'm not getting into a context of why we would want to do this. There is a calculus reason of it's much easier to work with additions of things than multiplications of things. So that's why we look at it. But like I said, tomorrow, or the next video, or the next lesson would be going the other direction. In other words, I'm going to give you that, and I want you to write this as the answer. All right, and that's a little more important for us in terms of solving equations. All right, let's look at another one here, and then I'm going to stop this one. All right, so this one's a little trickier here. First thing I would want to do is I would want to change square roots to a power. So that's a 1/2. Remember, square root is a 1/2. We'll leave the 8. You don't need to break down 8 to like 2 to the 3rd or anything like that. Next, you got to kind of do things in order. You're not going to bring the 1/2 out in first because the 1/2 is only on the 4x plus 1. We've got to break it up at division, and division is subtraction. So this would become minus ln of 8. Now, the only other thing to do is we have to move that power out in front. And that's it. We can't do any more. I know you guys want to break that part up there, but we can't. There is no property. If you go back to your properties, there is no property that says ln of x plus y equals something. Okay? There is nothing. There's no way to separate that. You don't distribute ln. Okay? This is not equal to ln x plus ln y. That doesn't work. Okay, so when you have the parentheses there of addition or subtraction, then that's it. Okay, all right, we're going to stop there. I thought that was the last one. I'm going to do another video for this lesson because I've run out of time that goes over a couple of the problems that I'm going to assign you, and we'll have the homework as well.